this one looks a little more similar to the one he has on the practice exam. But we're going to do this the exact same way that we did the last Riemann sum problem. Again, I just want to write down, and it's probably good to write down what your formulas are, just to make sure that you don't forget them or accidentally make some dumb mistake. That's k is equal to n plus 1 over 2. And then the sum k squared. Move this over a little bit. K squared is equal to n plus 1, 2n plus 1 over 6. All right. So, yeah, so it should always be equal to 1. I don't think he's going to have you like re-index the summations. I don't think that was... I did look through the chapters, but I don't remember if they went into re-indexing or not in the textbook chapter. They might have briefly, but I really don't think he's going to give you one where the k doesn't start at 1 or 0, but if it starts at 0, it really doesn't make that much of a difference. Yeah, I would just assume that it starts at 1, because I don't think y'all know how to do that, or haven't really been taught how to do that. So yeah, I wouldn't worry about it, honestly. But yeah, like I said, we're trying to find the sum of this, right? So just like last time, we want to just rearrange this into a form where we can directly substitute these little formulas. So we're going to bring that 5 on the outside of this first one. And then we're still left with this summation starting at k equals 1 to 200. And then we're left with that 1 on the inside. So I'm going to write parentheses around those just to make sure that I check that one off. And then we're subtracting our next one. We're going to pull out that 1/2. And then we're going to have that summation of 64 to k equals 1 of k. Again, looks very similar to this one right here, except obviously we have our n, which we will need to solve the problem. And then we're going to factor out that 6 of the last summation. And our n is 105, and then we're still left with that k squared. So all I did was use that constant multiple rule where we pulled out our multipliers. Right? We pulled out that 5, we pulled out the 1/2, and then we pulled out that 6. And since those summations look very similar to the identities we have, except for the n is a number, we can substitute for that formula. Before we do that, let's just write down our n values. So our first one is n is 200, second one, our n is 64, and our third one, our n is 105. So from here, we are going to have 5 times 200, right? Because our formula just says n for that first one. And then we have minus, still have that 1/2 power, or 1/2 multiplier, and our n is 64. So using that formula, we get 64 times 64 plus 1 over 2, plus, and then we have that 6. And then our n is 105. So we have 105 times 106. 2 times 105 is 210 plus 1 all over 6. All right. So then from here we get 1,000 for our first one. And then we end up with 64 times 65 over 4. And then plus those 6's are going to cancel out. And then we're left with 105 times 106 times 211. And honestly, from this point, I would just plug it in your calculator. And the answer you should get from that is 2,348,390. So do you guys see what I mean by the process is pretty much the same if you kind of structure it that way every time. And I'm going to send the attendance link since it is 6, and we are going to move on to the practice exam. But yeah, for those of you that have joined recently, please sign in. It'd be very